This is Senior Algebra, Section 2.7, Application Problems with Linear Equations. Today we're looking at some mixture problems, percent problems, some money problems, and some distance rate time problems. In the first example, we're looking at concentration amounts here. And when we think about this one, I want you to think about when it says there's a certain percent of an amount here. Okay. If I said with 20 liters, 50% of 20, well, how would I figure out 50% of 20? Well, I would be multiplying the amount times the concentration. So I want to figure out 35% of 40 liters. So I'm going to take the amount, 40 liters, times the concentration, which is the percentage here. And that's going to give me my amount, in this case, of pure acid. So I'm going to take 40 liters times 35%. The 35% I'm going to convert into a decimal, move it over two places. Remember, percent, per means divided by, century is 100. So 35 over 100, which is 0.35. When I take 40 times 0.35, I get 14 liters. That means there's 14 liters of acid in that mixture. So 40 liters total of the solution, 14 liters is acid. In B, I'm looking at a similar problem, in this one involving interest here. So to figure out interest, I'm going to take the amount that I am investing, the principal it's called, times the percent interest I would get. So in this case, I invest $1,300. I invest it for 1 year. So I'm going to earn 7% of 1,300. 1,300 times 7%. Remember, 7% is 0.07. Make sure not to put 0.7. Move the decimal point over two places, 0.07. When we multiply that, that's going to give us our amount of interest, which is $91. So we use this idea here in example 2. It says a chemist needs to mix 20 liters of a 40% acid solution with some 70% acid solution to obtain a mixture that is 50% acid. So how many liters of a 70% acid solution should be used here? So I'm going to start by thinking about my amounts here. How much is in each? So how much of the 40%, how much of the 70%, and how much of the 50% do I have? Well, the first one, I look at the 40%. What amount do I have of the 40%? I have 20 liters. It tells me that. So I have the 40%, I have the 70%, and the new 50% mixture here. How much of the 70% do I have? I have some 70%. Doesn't tell me how much. So that's going to be my X. That's what I'm going to end up trying to figure out. Now the difficult one is the next one here. How much of the new solution do I have? What's the amount? Well, if I put some of the 20, if I put 20 liters plus X liters in, the new solution is 20 plus X. So since I have the amounts now to figure out the actual acid, I'm going to create an equation. Again, amount times the concentration gives the amount of acid. Okay, so we reference that idea here. So I'm going to take my 20 liters of the first solution and times it by 40%. The amount times the concentration. And I'm going to add it to my second one, the 70%. So again, the amount, which is X, times the concentration, which is 70% or 0.7. I know when I add those together, I want it to equal a 50% solution. So I'm going to take 50% times 20 plus X. Again, the 20 plus X is the amount of the 50% solution. So then from here, I'm going to solve it here. You have options here. I'm going to take 20 times 0.4, X times 0.70, and then I'm going to distribute the 0.5 to 20 and X here. So 8 plus 0.70X equals 10 plus 0.5X. Again, 0.5, that's 50.50. So I'm going to move stuff over. I'm going to move my x's to one side, my constants to the other. I'm going to subtract 0.5x. When I divide by 2, I get x equals 10 liters. So what did it ask me? How many liters of the 70% solution should be used? I should use 10 liters of the 70%. In example 3, we're looking at a bank teller here, and we want to figure out the number of each denomination bill he has. So in this one, I have $10 bills and I have $5 bills. It says I have 25 more $5 bills than 10. Do I know how many $10 bills I have? No. So that's going to be my X. My $5 bills are X plus 25. Now this is where it becomes a little bit tricky because it tells you the value of the money is $200. We have only the number of bills. So if I tried to add these together, if I added X and X plus 25, that would, again, just give me the number of bills, not the value amount. Okay? So I have to figure out the value amount. So if I had, let's think of this. If I had 8 $10 bills, how much money, what's the value of the money that I have? How would you figure that out? Well, I'd take 8 times 10 or get 80. So I'm going to take the number of bills times the value of it. So I'm going to take 10 times X. How many $5 bills? I'm going to take 5 times X plus 25. I distribute, I solve, I get 15X equals 75. So X is going to be 5. How many of each denomination bill do I have? So X was $10 bills. So I have 5 $10 bills and I have 30 $5 bills. And again, we should write a sentence here. There are 5 $10 bills and 30 $5 bills. In example 4 and example 5, we're looking at distance, rate, time problems. The controlling idea here and the controlling equation we're going to use is distance equals rate times time. Now you already know this. Okay, if I asked you if you're driving in a car and you're going 50 miles an hour, and if you drove for 4 straight hours, how far would you go? Well, you take 50, the rate, times the time, 4 hours, 50, 50, 50, 50, that gives me 200. So it's a D equals RT problem here. So I'm going from Madison, and I'm going south on I-90 here. It sometimes helps to make a drawing of this. So car number 1 is driving south, car number 2 is also driving south. So they're kind of driving parallel to each other here. I want to know when their distance is going to be 24 miles apart. So car number 2 is driving faster. When will they be 24 miles apart? So I'm going to figure out a distance here. So in how many hours will the distance be 24 miles? So I think about it like this. The distance car number 2 traveled minus the distance car number 1 traveled. I want that to be 24 miles. So the difference between those distances to be 24. Now, I don't know the distance for car number 2, but I can use the equation to figure it out. Whenever I have distance, I can do rate times time. So if I think about it, it says car number 2's distance. Okay, that's the rate times the time. Car number 2 is traveling at 63 miles an hour. For how long? We don't know. That's what we're trying to figure out. Some amount of time. Car number 1 was traveling at 55 miles an hour for the same amount of time. It says they left at the same time. And it equals 24. At this point, it's a pretty easy equation to solve. I get 8t equals 24. So t equals 3. Now, what are we in? 3 minutes, 3 hours, 3 days. I'm in miles per hour. So in this case, I am in hours here. So it's going to be 3 hours, which makes sense. If I think about it, the easier way to kind of go about it, okay, in 1 hour, there's a distance of 8 miles between them. So after 3 hours, there's a distance of 24 between them. So the last one, example 5, in this one, you're leaving from Milwaukee. One plane is traveling west, the other plane is traveling east. In this one, the distances are not being subtracted, but you're finding the total distance between them. So in this case, I'm going to take the distance I traveled from Milwaukee to Seattle plus the distance I traveled from Milwaukee to New York, add them together. So it says in 30 minutes, the planes are 275 miles apart. I could draw a plane there, but we know my drawing skills aren't very good. But I know that the distance is 275. So I'm going to add those distances together. The distance from Milwaukee to Seattle flying, distance from Milwaukee to New York that were in the air. Now, we don't know the distances, but we do know the rate time. So I'm going to use that idea here. It says in 30 minutes, the planes are 275 miles apart. So in this case, I know 30 minutes. Well, what do I have to do in 30 minutes? One flies 50 miles an hour faster than the other. Okay? So from Milwaukee to Seattle, the time is 0.5. Well, how did we go from 0.5, 30, what is that? 30 minutes. We want to be in hours here, so 30 minutes is how much of an hour? Half of an hour here. I could take 30 minutes divided by 60 minutes and get my 1/2 as well. The times are the same because they left at the same time. Now the rates. What does it say? The plane heading towards east is 50 miles an hour than the plane heading west. So I don't know the speed of the west. I'm going to use x. I do know that the speed of the east was x plus 50. So I'm going to take the distance I traveled from Milwaukee to Seattle, that's d equals 5x, 0.5x, plus the distance from Milwaukee to New York that I've flown so far, 0.5 times x plus 50, and that equals 275. I solve it, I distribute, 0.5, half of 50 is, yeah, that's 25. I get 275, so 0.5, that's 1, that's nice. So x is 250. Now, what do we again? It's a rate here, so it's 250 miles, that's the distance, and then we're in hours here, so miles per hour. I suppose you could do it in miles per second or feet per second, but again, I would suggest, since we have the mph, miles per hour, that's what we would use there. So the final sentence that we should probably put, the plane heading towards Seattle is going 250 miles per hour. The plane heading towards New York, which we don't actually have to find, but the plane heading towards New York is 250 plus 50, or 300 miles per hour. Sorry for getting the video up late. Your quizzes are corrected and should be an Infinite Campus.